Hello everyone. Welcome back to another episode in which we are studying Chapter 2 of Class 11th. We have studied functions, and previously in functions we have studied about its definition, domain, range and codomain. Some special functions like identity function, constant function and modulus function. Today also we will going to continue to study about functions and some special functions like signum function, polynomial function, rational function and greatest integer function. You may remember that we have given you an assignment. In assignment, we have asked you a question that to find the range of the following real functions. These are the three functions in which you have to find the range. The first one is the set of all non-negative real numbers. In the second case, we are getting the set of all those real numbers which are starting from 1 till infinity and 1 is included. And in the third case, range is coming out to be the set of all non-positive real numbers. We have also told you and asked you to study about the graphs of these functions. Viewers, you may see that mod x minus 1 will form a graph like this. Whenever x is equals to 1, f of x is 0. The graph that we have, this is mod x and the graph will shift towards the right. In hx, the graph will move upward. When x is equals to 0, what is the value of hx? It is 1. So this is the graph of hx. And last, third case, negative of mod x. What was the graph of modulus x? And if a negative sign is attached towards it, we know the range is coming from minus infinity to 0, where 0 is included. That means all those points which are coming upward from the x-axis, all those graph will become downwards. All those points become downwards. So this will be the graph of negative mod x. Understood? So let us see some more special functions, which is signum function. In the signum function, it is a real valued function where f of x takes 3 values. Whenever x is positive, it will take 1. When x equals to 0, the value of the function becomes 0. And when x is less than 0, the value of the function becomes negative 1. It is easy to plot and you may see the graph in this. You may see that this point 0 is representing f of 0. This, that whenever x is greater than 0, f of x is taking 1 as the value. So it will be aligned parallel to the x-axis and it will be in the positive side. When x is less than 0, that is when we are taking all the values which are on the left hand side of the real line, then f of x is coming out to be negative 1. So it will be a constant, that means a parallel line below the x-axis. So what will be the domain and range? Domain is R, the set of all real numbers. And range is, how many values it is taking? 3. So range is 1, 0 and minus 1. You may notice that we can write this function as this as well. Why this so? You may notice, if we break this function, it is modulus function. So modulus function, when x is greater than 0, what values will it take? For x, positive x. So positive x by x gives you 1. When x equals to 0, yes, it is already defined, it is 0. So when x is less than 0, then mod x will take which value? Negative x. That means whenever x is taking negative values, then the negative of the negative x will be the value of the function. So this gives you -1. So this how we are given with this function, and this function is known as signum function. So let us take this question. In this we have to find the domain and range where the function is defined as modulus x minus 2 upon x minus 2, where x is not equal to, and whenever x is equals to 2, the function is taking 0 as its value. Now, you may notice after simplifying it that it is nothing but converting into a signum function. F of x is again taking 3 values, 1, 0 and -1. Whenever x is greater than 2, equal to 2 and less than 2. Okay? Range is coming out to be 3 values, 1, 0 and -1, and domain the set of all real numbers. So what will be the graph of it? Let us see. Graph is again the same, but here the function, as we know, the break where the function is breaking, it is breaking at 2. So we will going to see that whenever x is equal to 2, the value of the function is 0. So this point. And whenever x is taking all those values which are greater than 2, so a line parallel to the x-axis where the vertical distance remains the same, which is 1. When x is less than 2, then it is taking value -1. So it forms a parallel line below the x-axis where again the distance remains to be 1. Let us take one more example where we are finding the domain, range, and we observe the graph of it. F of x equals to x square. Domain is clear. What is the domain? It is taking all real numbers, so the set of all real numbers will be its domain. Range. Again, it is a square function. Whatever value we are going to put in it, positive value will be there. So let us put some values in it. If I put 1, so f of 1 is equal to 1. F of -1 is also 1. F of 1.2 is equal to 1.44. And if I find the value of -1.2, then it is coming out to be 1.44 again. So you may notice that each and every time we are getting a positive value. So range is all the set of positive real numbers. And is 0 there in the domain? Yes. So it must have an image. So image of 0 is again a 0. So 0 is also included in the range. Okay. So for this, let us see the graph of it. Graph is like this, where you can see that y-axis is acting as a symmetrical line and the graph is same what is there in the first quadrant. Since we are having all positive real numbers, so the value of graph will be in the upward portion of x-axis. No graph will be there in the negative part of y. So such functions are said to be polynomial functions. So polynomial functions are those real functions when for each x in R, f of x is equal to some polynomial, where n is taking non-negative integer and all these constants a0, a1, a2 and so on till an are constants coming from the set of real numbers. That means they are all real numbers. So let us take one question on it. Here f of x is equal to a polynomial function which is x square plus 1 and we have to find the value of this given expression. In this, what values we have to first find? F of 3, f of 1. We have to first find the image of the element 3 and 1 of this polynomial function. So on putting the value, what is the image of 3 in this function f? It is 9 plus 1 gives us 10. That means 3 is mapped to 10. And 1, image of 1 is 2. So f of 3 minus f of 1 upon 3 minus 1 gives us So 4 is the value of this expression. Now we will going to study about rational functions. Rational functions are functions of the type f of x by g of x, where this fx and gx are both polynomial functions, provided g of x should not be equal to 0. Let us take one example, 1 by x. What will be the domain of this function? Will it be set of all real numbers? No, it will not be. Why? As we can see, at x equals to 0, this function is not defined. So the domain will be the set of all real numbers without 0. Now, on plotting the graph, it is interesting to know that the graph of this function will form like this, that whenever we take x bigger and bigger, the value of fx will come closer to 0, but it will not be 0. Similarly, like this, when we take value of x smaller and smaller, the value of fx will be closer to 0, but it will not be 0 again. Such graph is said to be a rectangular hyperbola. Now, from the graph itself, can you tell me what will be the range? Range is set of real numbers, full R. Again, will be 0 there in the range? No. So it will be the same as of domain. Okay? Now, next special function that we are going to study in this are greatest integer function. It is a very interesting function. What its function says? It is a real function where f of x is equals to this. This is the notation of greatest integer function, which assumes the value of greatest integer less than x. The graph of this function is very interesting. You may see that it looks like steps, and that's why it is also called a step function. Let us study how we are getting its domain and range. Domain, it is clear that we are finding image of each and every real number, so domain will be the set of real numbers. Let us study what will be the values or what the definition says. First, we are going to break a real line into parts. This is 0, 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3 and negative 4. So whenever my x is lying between 0 to 1, what will be the value of fx? As it says, greatest integer less than or equal to x, right? That means whenever my x is lying between in this interval, always the function, the value of the function fx will be 0. If x is taking 0.5, the value will be 0. 0.3, again the value of the function will be 0. And if x is equal to 0 also, then again the value of the function will be 0. Next, interval is this. Now you may see that what will be the function, value of the function when my x is lying between the interval, between the points 1 and 2, that is x is lying in the interval 1 and 2. The answer will be 1 every time, and this is how we are getting our step function, steps. Okay. First of all, you may notice in this that the range is coming out to be what? Each and every integer values. Let us take one more interval, say suppose this one. So whenever my x is coming from the interval -1 to 0, then what will be the value of the function? Value of the function will be greatest integer less than or equal to x. X, the integer which is attained before x is -1. It cannot take 0 as a value. So, -1 will be the value of this function. So, what will be the range? Range is the set of all integers. So, let us take now one question on it. In this, f of x is given to be this function, where this is representing a greatest integer function. We have to find the values f of 2.5, f of 1.3, negative of 1.3, and the value of the function when the element is 3. In this case, what we are going to do? We will put the values 2.5, -2. So that means 2.5 is lying in which interval? 2 and 3. Where 2 is included but 3 is not included. That means what will be the value of this function? 2. So answer will be 0. Now in this case, -1.3. So what will be the value of this greatest integer? What will be the value? What will be the integer associated with this? It will be -2, because -1.3 is lying in the interval -2 to -1. So this will be -2, with -2 gives you -4 as a value. Last, f of 3. Whenever there is an integer value, the value of the greatest integer function remains the same. So this becomes 3 minus 2 gives us 1. Hope you have understood how we have to find the values of the greatest integer function. So let us summarize what we have done today. So we have done some more special functions, which are polynomial function, rational function, signum function, and greatest integer function. Hope you have understood. Thank you.